When working with LLMs, one of the most common techniques is using a vector database to store external information that your LLM can look up in order to provide accurate and contextual answers. In order to do this, that information is first converted into numerical coordinates called vector embeddings, and then those embeddings are stored inside a vector database. If you want more details about vector embeddings, check out my video on RAG. Otherwise, you can just remember that a vector database is where you store your embedded external information so that your LLM can look up that information when providing answers. In this video, we're going to dive into a popular vector database called Pinecone DB. I will show you how to interact with the UI and also interact programmatically using the Python SDK. Let's start by going to a browser and opening up Pinecone. You can get there through app.pinecone.io, and I did add a link in the description. And the first thing you'll need to do is, of course, create an account. There is a free tier, so once you have your account created, you'll see something that looks like this. If you go down here to the bottom left, you can click on this information icon, and it shows you what you have available in the free tier. I find that for small projects, it is more than enough to get you started. You get up to 5 serverless indexes, 100 namespaces per index, 2 members, and community support. You'll also have a healthy amount of reads and writes and storage available. Another place you can go to look at the different tiers is in settings and then plans. And right here, it shows you all the different plan options, starting from the free version all the way up to enterprise. I also want to point out some documentation, which I also have provided links for in the description. This is a good getting started documentation, so please check that out if you want to. So let's go back to the home page and let's start off by creating an index. All you have to do is go over here to database and click on create index. Okay. Now an index is, you can think of it as like your database container. It's basically just the container that holds your vector embeddings and keeps them ready for searching. Now let's give it a name. I will call it UI demo because I'm going to be doing a demo both in the UI and with the Python SDK. Below are the embedding models. An embedding model is just a type of LLM that is used to convert text into vector embedding. So it will convert your text into a list of numbers, basically, that are coordinates. There's a few different ones available, but we'll just do the Llama Text Embed v2 version. And then you can see the details down here. We need to choose a field map, which is basically just the field of our data that we want to embed. And we can change this, but by default it's text, and we'll just leave it as text. All right, and then we choose our cloud provider. That's where the storage will actually be saved. We have to choose AWS on the free tier, but if you have the upgraded tiers, you can choose GCP or Azure. And then with the free tier, we also are limited just to the Virginia, US East 1 region. Okay, so let's go ahead and click Create Index. Okay, so our index is created. You can see some of the details, the cloud provider, the region, the embedding model. You can see the record count is 0, right? So we haven't added any data or any records. So let's do that. And you can do that through the UI right here. There is a limitation through the UI. You can only upsert one at a time. So it's not really ideal for bulk record upserts. And that's where the Python SDK comes in handy. And I'll show you that in just a minute. So let's give it an ID. We can just start with 1. And then we're going to add some text that is kind of like a description of a pizza. Okay, so maybe we're getting this from like a menu at a restaurant. And maybe we want to be able to ask questions about a restaurant's menu. So this is one chunk from that menu describing a pizza dish. And then you can choose different namespace. A namespace is basically just a way to partition your index. So if you had like different categories, for example, in your index, it can help when you're doing search because you can filter down by namespace and more efficiently perform a search. And we can also add fields, which can also be used to filter or just provide metadata. But we will not. We'll just keep it simple and just have our text field, and then I'll click upsert. Okay, so now you can see that we have 1 record added. And if you, just for fun, if you go to these 3 dots and click fetch, you can see what that embedding looks like, okay? So it's just a list of numbers. You can think of them as coordinates in a multi-dimensional plane. In fact, we saw when we chose the embedding model that this is converted into 1024 dimensions. So what you're seeing is just a small part of this whole vector. There's 1024 of these comma separated values. So that should just help you kind of visualize what's happening. And then just for fun, let's add 1 more record. And this one is going to be a drink description. So we'll give an ID. We'll keep the namespace as the default. And this is a description of like a coconut water drink. And then let's hit upsert. All right, so now we have our 2 records. And now that we have records in our index, we can search against it. So top K just means how many search results do you want to see. Let's just return 2 records. And then let's say we want to search and we want to say refreshing drink in our search, okay? And then we choose the operation. And the search by text is performing, if you look at the details, a semantic search. So it's not just a text match, but it's actually finding meaning. What's happening is it's going to convert this text into an embedding using the same embedding model that we use to create these records when upserting. And it's going to search all the records and find the closest match to the embedded version of this text. Okay, so let's hit search. And what it does, you can see, is it gives it a score. So this one got 0.5364. And this one got 0.0833. And it makes sense because the coconut water got a higher score than the pizza, which we would expect. And then there is another type of search, or a way to add to the search. It's called re-rank. Like, you can think of a standard search as like casting a wide net and doing a quick search, grabbing the top candidates. And then a re-rank kind of acts like a second pass filter. So it takes like your candidates that were found in the first pass, and then it does some more analysis on them and reorders to get an even more accurate answer. So let's go ahead and run that search. We can choose models here, but we'll just do this one by default and search. Okay, and then you can see that it was able to say this one is a 0, like it almost has nothing to do with what we were searching for, which is true. And then it gives this one an even higher score. So it's able to even get more of a separation between the two results and more confidently say that this is a solid match on what we searched. So that is how to get started interacting with the UI. What we've done as a recap is we have created an index and we've upserted records, and then we've performed searches against those records. Okay, let's jump into the code now. So we will start working with the Python SDK. I have a link in the description to this documentation that tells you all about Python SDK. And a lot of this information is what I'm going to show you today. This is really helpful documentation, so I encourage you to use it. We will obviously be working with Python. I'm using 3.11.9 and I'm using VS Code, but you can use any code editor that works for you. So first things first, we need to install the Pinecone package. And we are also going to be working with this python.env package that helps us authenticate with our Pinecone account using the API key. I'll show you how that works in a minute. I already did the pip install to save some time. Next thing we need to do is import the libraries from these packages. So I'll run that. We are importing a load.env function from the python.env package, and then we are importing the Pinecone class from our Pinecone package. So let's go back to the UI real quick because we need to generate a API key. And so you go here to API keys underneath manage, and all you do is click the plus button, give your API key a name. It can be anything, and click create key. All right. Then you'll copy your key, and going back down into your code, you can open up a file called .env. All right. That it needs to be in a file called .env. But for this demo, I'm just going to show you a file called .env demo because I don't want to actually show you my API key. And then you'll paste your API key right here after this keyword Pinecone underscore API underscore key in all caps, and save that. So then when you run this load.env, it's going to look in that env file, find your API key, then we're going to save the API as this variable. Now you don't have to do that. You could just hard code the API key right here, but obviously that's not best practices for security purposes. So that's why we're loading it into the .env file. All right, so now we have that saved out, and we will initialize our Pinecone client using the Pinecone class and passing in our API key. And then we are going to create an index, just like we did in the UI, but we're going to do it programmatically. So we have our Pinecone instance, and now that we have that created, we have access to all the different methods and attributes of that Pinecone class. And one of the methods is create index for model that we can use to create a new index. So we pass it a few arguments. The first one is the index name, which is saved up here as code demo. And like you saw in the UI, we have to use the AWS cloud provider. We have to use the US East 1 region. And then we are passing in the same model, llama text embed v2. And then we choose the field that we want to embed. And in this example, we're going to call it chunk text. And then before we do the creation, we do a method called hasIndex to check and see if that index already exists before creating it. So let's go ahead and run that, and that will create a new index in Pinecone. Okay, let's go check it out in the UI. Go back down to databases, and there it is, code demo. Okay, so let's click into it. And we have our new index. It does not have any records yet though, okay? Oh, one thing that I meant to point out earlier is in this metric tabs, there's some useful information. Once you start actually interacting with your indexes, you can look at the activity, the number of reads, the writes, requests, the latency or the performance of your queries, and you can look at storage size and record count. So just keep that in mind. And we are going to upsert some records now. So going back to the code, here are the records that we are going to upsert. If you look closely, you will notice that what we have here is the rules of the game of Monopoly. If you haven't played that before, it's just a board game. What we have here is essentially if we had taken the rules or the instructions of the game of Monopoly and broken them up into chunks. Okay, so this first chunk, each player chooses one token to represent them on the board and begins at the go space, right? And so you can think if we wanted to build a chatbot that we could ask questions about how to play Monopoly, we would take those instructions and break them up into smaller chunks and save them in a vector database that our LLM could use to look up the rules of Monopoly and give you answers. Okay, so we're pretending that we've already chunked up the instructions and have saved them here in this records variable. And you notice that it's all just a list of JSON formatted objects. We have our ID, we have our chunk text, and then we also have a category to go along with it. All I'm doing right here is saving it into this records variable. You can see there are a lot of different chunks. There's 20. And then at this point, we are ready to do the upserts. So we need to save an instance of our index. So we do that by calling PC and this index method. And then we pass in our index, which is a code demo. And then we call this upsert records method. And we're going to use the default namespace. And we will pass in this list of records. So I'll go ahead and run that. And once that's done, we'll go ahead and check it out in the UI to make sure it looks good. Okay, let's go back to the UI real quick. And it looks like it's refreshing. Okay, there we go. So you can see our record count up here is 20. And then if you scroll down, you can see all these different records. But we can view some of the statistics programmatically by using this describe index stats method. And then I'm just going to kind of loop through some of the important attributes that it returns. So we have our dimension, which again is how many comma separated numbers are in our vectors, and then the total vector count is 20. Okay, and then if we scroll down to here, we can do a semantic search against our index. Just a reminder, semantic search means that we're looking for meaning, and we're not just looking for a text match. We do index.search, and then we pass in a few different arguments. We use our default namespace, and then for our query, our input needs to be formatted like this, so text, and then whatever the prompt or the question is. And so in this example, we're asking what happens when you pass go. Top K, you already know what that is. That's how many answers we are going to return. And then we are specifying the fields that we want to see. And just as a reminder, what it's doing is it's converting this question into a vector embedding with 1024 dimensions. And what it's doing is it's going into our index and it's searching through all the records and it's finding the closest match to the embedded version of this question. And then we are telling it we want to return the category and the chunk text fields. So let's go ahead and run that. And I'm going to go down here. We've saved those results into this variable, and I'm just going to loop through the results, some of the attributes that we care about. Okay, so we got the top two, right? For the first one, we got a score of 0.37. It gave us the category and then the text. Okay, passing go entitles you to collect a salary of $200 from the bank. And then for the second one, we got a slightly lower score of 0.35, also gameplay category. And it's talking about if you roll doubles. And I think the reason it gave this as a match is because it has something about go. It uses the word go, and I think it matched off of that. Okay, so let's just like we did in the UI, let's do the same search, but let's use re-rank. And as a reminder, that's a second pass on our initial search results. So just like before, we will be using this search method from our index object, the default namespace, the same query, what happens when you pass go, the top two results. Then we do the re-rank, and we have our re-ranker model, and we still want the top two results, and we want it to check the chunk text field when doing the re-ranking, okay? And then we're going to return the same two fields, category and chunk text. So let's run that and see what it looks like. And again, let's print out the results. Okay, so you can see now it gave the text about passing go a 0.96 score, so much higher. And then it gave the other one a 0.006 score. So this one did a lot better because it was able to separate those two. When we did not do the re-rank, the scores were very similar, even though the second one was clearly not very relevant to the question. When we did the re-rank, you can see the separation in score is huge. So it's clearly saying that this is the best answer and this one's not that great of an answer at all. Just as a recap, using the Python SDK, we created a new index, we upserted records into that index, and we performed a semantic search and then a semantic search with re-rank. There's certainly much more you can do with Pinecone, both in the UI and through the Python SDK. This is just an introductory level video. I will be doing more videos, so stay tuned for those. I hope this was helpful. If it was, please like the video and subscribe to my channel. Thank you.